Welcome, guys, to another set of notes. I'm going to apologize right now because I don't know if it sounds weird to you, but my voice definitely sounds a little weird to me. That's because my nose is really stuffed up, so I guess we're just going to have to deal with it. These notes are going to go on page 20 of your notebook, okay, and we're going to be talking about independent and dependent variables and what that means, and then this thing called correlation. So, hope you're ready. Here we go. Okay, here's your goal. Okay, right there. Okay, your goal is that after today, you're going to be able to explain the differences between independent variables, dependent variables, and correlation. Okay, the variables are kind of similar, but correlation is a little bit different. Okay, relations is the big idea. Okay, in math, we have x variables, we have y variables. We don't always use x and y like we've done before. We might use an s, we might use a t, we might use a c. Okay, I might use a w. We have a bunch of different variables, but we still call them the x variable and the y variable because on a graph, okay, this is the x-axis, that's the y-axis. Okay, on a table, that's usually the x, that's the y. So they might be different variable names, but they're still the same locations as the x and the y. Okay, you can sort of think of them in a relationship, the x and the y, in a relationship like boys and girls are in a relationship. Okay, and if you'd like, because we're going to use this later on, x, they're the girls, okay, and y's, they're the boys. Okay, now, dependence. Believe it or not, every relationship, there's dependence. Okay, something depends on something else, or someone depends on something else. Okay, an example would be like you kids, you depend on your parents, whether you want to admit it or not. Okay, your lungs, they depend on air. Okay, and for some of our more shallow viewers, your happiness may depend on money. Okay, but bottom line, most things depend on other things in a relationship. Okay, independent and dependent variables. Okay, the word independent, okay, it means it doesn't answer to anybody. Okay, it doesn't change unless it wants to change. Okay, it is in control. Okay, the independent variable is in control. We get to choose what it is. Okay, the dependent variable is just kind of along for the ride. Okay, it does not change until the independent changes. In order for the dependent to change, okay, in order for the dependent to change, the independent has to change first. So this changes first, then that follows. Okay, in math, the x variable is the independent. Okay, girls are the independent ones. Okay, they change when they want to. Okay, boys, you kind of change when the girls change. Okay, if a girl all of a sudden starts liking the new Katy Perry song, you might start liking the new Katy Perry song too, just so they'll like you. But bottom line, X is the independent, Y is the dependent. Okay, this little sentence here, why depend on your X? Okay, it's written kind of like a real life scenario, like a question. Why do you want to depend on your ex-boyfriend or your ex-girlfriend? You don't. Okay, but if we translate to a math sentence, it's going to be why depend on X. And instead of a question, it becomes a statement. Okay, the Y variable depends on the X variable. Okay, and then something that we're going to have to deal with. Okay, 99 times out of 100, time is independent. Okay, when I say always, I mean 99 times out of 100. Sometimes it won't be, okay, but time is 99 times out of 100 the independent. Easy enough? All right. Let's look at correlation. Okay, in math, correlation is the direction of the relationship. Okay, it's either positive, whoa, whoops. Okay, it's either positive, which means it's going up, it's negative, which obviously means it's going down, or it's no correlation, it's just kind of going blah. Okay, in a positive correlation, okay, it means the relationship is doing well and it's going up. So if I have a graph here, here's my x, here's my y, okay, it kind of looks like this. Okay, the x variable, it keeps increasing, it just keeps going up and up and up. The y variable also goes up. When they both go up, that line looks like that. On a scatter plot, it'll look something like this. Okay? Notice it's not a perfectly straight line, but if I was to draw a circle around the points and then cut that circle in half, it sort of creates a line that goes up. Okay? That's positive correlation. Negative correlation, however, obviously, is the exact opposite. The word negative means it's going bad and it's going down. Okay? In a negative relationship, kind of in real life, okay, sometimes if one person is happy, the other person is feeling bad. So as the x gets more and more that way, okay, the y starts going down, okay, which kind of creates the down line. Okay, or as the x goes up this way, okay, the y, or I'm sorry, as the y goes up this way, the x kind of has to backtrack and go that way, which still makes it go down. In a scatter plot, it's the same thing. Okay, again, not a perfect line, but if I drew a circle around the data, and I drew a line through it, it would kind of go down. Okay, no correlation. No correlation means no relationship. Basically, in a no correlation, it's just kind of like that. Okay? On a graph, whether it's a scatter plot, it would just be all over the place. If I drew a circle around this and a line cutting it in half, okay, there would just be a straight line like that. That's pretty much all we have about relations right now. We're going to work more on it over the next 2 days. So hopefully you got it, and we can focus on understanding the trickier versions of it. See you guys tomorrow in class. Bye.